Welcome, Precious, to the rdev R-Chain learning uh, session, which I just got a call, where we've been going over the R-Chain tutorials so that we can all program applications to save the world on the new R-Chain world computer, or run our own R-Chain network and be part of the decentralized future. And where we start off, I'll put in the chat here, is the rgov .robot.net, and that's spelled RHOBOT.net because that's oops, it's the Rolang language. The language of R-Chain is based on the row calculus, which is a form of the process calculus. And why don't we start with the tutorial, if I can find it. And I will share. Oh, it's in progress. So once again, I'll share my screen. Okay, and this is the rgov development interface. Okay, and when it comes up, we'll see it's asks you to select an action here, and we have all these actions that we can suggest here. And let me let me start this. I think I made a mistake here. I have to select video, share video when I share the screen. Start out with Rolang, and we're going to learn about the row calculus and how the language Rolang relates to a very simple mathematical formulation that formalizes process orchestration. But the weird thing about it
Jim,
is, yeah.
Oh, okay. Sorry. Go ahead. It's if you can increase the volume a little, so it's like I'm struggling to hear. Yeah, that's
and maybe I should. I don't know where the settings are.
What are you looking for?
I was going to maybe play parts of it at 1.5 speed. It does everything at once. Okay. You know, it doesn't do things in a sequential order unless you force it to do so. Okay. Did you get that part? Should I replay it? You got it? Is anybody there?
Precious.
Can you replay, please? I didn't get.
The language Rolang relates to a very simple mathematical formulation that formalizes process orchestration. But the weird thing about it is it does everything at once.
Okay.
You know, it doesn't do things in a sequential order unless you force it to do so.
Okay.
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 You get it? I mean, that's clear, or a little bit too deep, you think, maybe? I do.
Well, I think it says
We're going to start out with the developer, the rgov governance developer interface.
Okay.
And normally we run this on our own local machine.
Okay.
When we're doing development, but we have a shared, you know, the ArtChain Developer Cooperative is running this machine, robot.net, where we run our common services and stuff.
Okay.
And we have an interface running here. It may not be up to date. Certainly at one point we'll show you how to update it, or you know, how to update your own local host instance. Okay, so so the match statement we see here is this is sort of an empty process. Okay, if we go to check the balance on an account, we get the Rolang code here to do that, and then we can connect your wallet and it fills in the amount. And what we can see is the match statement says give this name to the whole thing, to match one argument in the match statement. So if there's one argument in the match statement, it'll assign the name mygov rev address to that value. And there, you know, there's no let x equal 5 in Rolang yet. It is defined as part of the language, but it doesn't exist yet. And that's let statement is really syntactic sugar on the match statement. Now, if we put a more complex pattern here, we might have different alternatives. So this would be more like a select. If it matches one argument, do this. If it matched two arguments, do that. If it has a string or the value 25, whatever, whatever. But we'll learn more about the match statement later. For now, it just assigns the name. It matches one argument and it assigns the name to a value. Okay, so we shouldn't call it a name because that's ambiguous and has a formal meaning in the row calculus. We should call it an identifier. And what it does is it binds that identifier to the value. Any questions?
Oh, okay. Okay, there's a statement that that was made that for now, it's not like x equals to 5 as a syntactic statement. I don't know if you can throw more light on that.
So you have no questions?
Hello?
I think Jim, he was saying that he didn't really understand the parts where Golang doesn't have assignments like other languages. You know, for example, in JavaScript, you could say variable A is equal to this, but it's a little different in Golang. So that's what he was talking about. That's what he said
Yeah.
he didn't understand.
Right. And sometimes, you know, you want to see it more clearly. Whoopsie daisy. Let me go to here. Now we have a match statement, and I'm going to match 3 to X. Okay, and then, well, I have to introduce a name, and this will come up shortly in the video. X in X, right? Hello, and I think I do this in the video, so I probably don't need to do this again. I'm not sure it would help. Oh, no, I can't have both X. About Y. So this is the output command, and I probably should have just continued the video. But if I explore this, and if I put enough end braces to match, I'll say hello. I put in X, and I want the value of X, so I have to change the name X to a process, because, and you'll learn about that in a minute. Uh-oh. Variable X used in the name context. Oh, I'm sorry. X is an identifier. It's not a name. And it's an identifier of a process. So we get 3. So we send processes, we receive to names. Y is a name. X is a process in this case. And number 3 is a process. If I put 2 + 2 here. Now, I believe I do this in the video. Maybe I wish I could speed it up. We get a 4. Assign X to 4. Do you understand that now? Is there a question about that?
Okay, okay, I can get it.
And right. And then the only things in Golang are channels and processes. And a channel name is a process that represents itself. The number 5 is a process that represents the number 5. Okay, one of the innovations of the row calculus over pi calculus is it has the idea of names that are unforgeable. So we can make new names like return, which is an unforgeable name, which means that it's totally secure. It's totally private. No. Okay, we're actually making the identifier return, okay, which is a name. Okay, as we saw, an identifier could be a process also. Nobody can access it. It's local within the braces unless I share it. Now, if I share it with someone, I'm giving them the capability to use that name and access the value. We don't really access the value of the name because the name is a channel. Name represents a channel, and we can only read or write to a channel. Let's go back to select an action here. Oops, doesn't go back, reload the page. Okay. So if I make a new X, I give it a context where the name X is available. Okay, now I can write a value to X. Add the exclamation point in Erlang. The way I write a value. X, right? Hello. And basically, the only thing that I can do in Erlang is read and write messages. Oops, I need parentheses. Silly me. Not sure why, but I need parentheses. And there's one special thing in our chain where the first name I introduce is the result of an explore operation. So if I explore this, problem, syntax are undefined.
Jim, can you pause a bit?
What did I do? It looks like I'm missing and then parentheses. Yeah.
Yeah, can you pause? I wanted to ask a question.
Sure. You can raise your hand. I think you can raise your hand in Zoom.
Okay. So, yeah, this just reminded me of a point. So I've been trying to understand, do you know why it is that the result of an explore is always the first new channel?
Well, the question of what should it be? You know, maybe some other power box function. It's possible they could make all the names available for you to read in the result of a explorer, but the only variable the only channel they give you is the first one. They don't give you all of them. In other words, when you do a deploy, you're going to poll and you're going to read on that first channel because you know what that first channel is. That's the only channel you know.
So what if you have another channel that has another return channel? Like another channel that is called return.
It won't print out. You won't see it in the result.
So what if that channel has a power box of standard out?
Then it goes to the log. It doesn't go to the result.
So result is always tied to the first channel.
Correct.
Okay.
And then brace. Why doesn't it do a new line? There we go. Obviously, our braces have to match. And we explore again. And we see we got hello. Isn't that nice? Let's create another value, another name. And we can send hello to Y. And we explore. And we get nothing. Okay. Nobody read Y. So besides writing, the other thing Rolex, of course, is read. We can read it. We can read a channel. So let's read it. And we basically do do a use a wait for, which is a for. For is not a loop. Everybody calls it a loop, but it's not a loop. For is a wait for. So we introduce a name, Z is what we're going to bind the value we read from Y. Right, we introduce an identifier, which is a name. No, I'm sorry. And then we're going to do some code. It's a value. This name is the value that we read from the Y channel. So when we match a pattern of one element in the channel Y, it's going to trigger this. It's going to trigger this code, and we can say we can write to X. We can write. We can write Z, and we can use the concatenate operator to concatenate plus is concatenation in Erlang. World. Oops. Okay, and now we can execute this, but we'll get an error because line 7, syntax error. Y doesn't like Y. Y doesn't like Y. Well, okay. At the end of this brace, we have no operator between the for and the right to Y, and the only operator we have is the par. Run these two things in parallel. So it runs the for and the right at the same time. However, this is not going to be executed until something is written to Y first. So we're forcing it actually to execute line 7 before it executes line 5. Does that make sense?
Yep, I think so.
You think so? Does that make sense? Questions?
Yeah, it makes sense. Makes sense.
Isn't it ridiculously simple? No.
No.
But there's a lot to learn. A lot to learn.
I don't think I understood why before we did this for Z to Y, why didn't new X, Y produce Y? Is that because X was not defined in any way?
I don't understand the question. I mean, this creates the unforgeable name Y, which,
Right.
or we call it Y. It's an unforgeable name. Actually, we can't forge the name, okay? But we can call it Y for now.
Sure. But when it was just new X comma Y in and then Y hello, it didn't run. And is that because we were doing nothing with X?
We were doing nothing with. No, it's because the first variable that we declare is the result.
I see.
Okay, so the only thing it's going to output is if we write something to X, it's going to output it. If we write something to anything else, it's not going to output it.
I see. Thank you.
Okay. Oops. We go still. Name variable Z 413 is used in a process context at 512. Well, this is one of the foibles of Erlang in that we're using a name in a process context. And we always send processes. Okay, hello quote is a process representing, it doesn't reduce to anything. Okay, if I put in par here, right to X 2 plus 2. Okay, 2 plus 2 reduces to 4. And then 4 is a process that is reduced as far as it can. 4 is a 4, period, right? Same thing with hello. Hello is a process that's reduced as far as it can be reduced. But we have to send a process and receive a name. We send a process to a name in Erlang. And here it says, oh, gee, we're sending a name to a name. We can't do that in Erlang. We have to send a process to a name. Well, we can cast a name as a process by putting a star in front of it. Okay, now, like the word hello, the unforgeable name Z represents itself, but as a process. That's a bit confusion with Rolang on our chain, actually. There are, yeah, I stated that wrong. The identifier Z is a process. Wait. And now the identifier Z is a name. I misspoke before. Because if it was a process, it should be, I don't understand. We'll see what happens. Some implementations of a subset of Rolang that don't give an error message. It's like doi, you wanted this to be a process, not a name. But Rolang and RChain enforces it because it wants you to be aware of the difference between a name and a process. And that can take a long time to be comfortable with. Yeah, I'm still learning it, that's for sure. Okay, so a variable Z used in a process context always means, oh, I forgot a star. Okay. Now we explore and we see if it works now. Aha! Now we can see that it got hello world, and it got 4 because we output it to X. It's considered part of the result for an explorer. Later we'll learn about deploy, in which case every deploy onto the blockchain. Explorer doesn't change the blockchain at all. It does nothing on the blockchain. It just runs the Rolang code. Okay, but it can be used for read-only functions. Suppose I want to read a value on our chain, but I don't want to do anything with it. Like I want to check my balance, but I don't want to pay to check my balance. I don't want to put another block on the chain to check my balance, right? Okay, and be sure to chime in with questions here.
I will.
So we learned 2 things. We learned the read and the write, and we also learned the match. Okay, we could have put in something like, we could have put hello here. And we could have put message here.
I can see Kyril's hand is up.
And we could have, I'm sorry?
I think Kyril's hand is up.
Question, can you hear me?
Yes.
So you can put the star inside the for comprehension, right? Instead of on line 5 on the Z unforgeable name, you can put it on in the for comprehension on line 4.
Okay. We can, now this worked. Okay, so Z is the name. We can make Z the name of the process by putting an at, and I think we're going to do that next. Put in message here, except I'm going to get an error. I didn't get an error. I bound the name. Okay, I bound the I confused myself here. Okay, because message is matched against the process. Hello. Message is a process, not a name. Okay, and I could do I could have put a star message here, and that would give me a problem. Name variable message used in process context on 7. Well, by saying that message that I'm making a process for message, I'm making it a name. So now I have to put a star here because I made message a name rather than a process. Is that confusing enough? Okay, so so I'm going to leave it as a process for now and see that it works. So it's a way of forcing a name to be a process, or a name. If that, I don't know. Probably we should say message is an identifier. that can be represent either a process or a name.
Sure, sure.
It's confusing when I call it a name. It's an identifier for the process. Hello. If I put a star here, then message is an identifier for the name of the process. Hello. That's just an identifier. That's I think a good distinction to make. Okay, so that's Rolang. Now you pretty much know Rolang.
Cool.
And there's a lot more coming. We had somebody join.
Hi, Jim.
Hey, Rich.
Hey. What's up?
Hey, hey, Rich. We've just been reviewing the Roland crash course. Did you get a chance to watch it?
Afraid I didn't. No. Hello, Precious. Hi. Well,
Hi.
is it okay?
Yes, that's my name. Please.
Pleasure
Nice
to
to meet
meet you.
you.
Nice to meet you.
So I guess we're here for the same thing pretty much. We're learning Rolang, and it looks like we have Kirill on board too. Now, what is it? What were you? You guys on a different hour than us this week?
We are, yeah. When do your clocks go forward?
Next week.
Okay. Now, as in not Saturday or a week on Saturday?
This Sunday that we change. On Sunday they
Yeah,
change.
does the calendar invite, does it automatically update to the time, or we have to do that manually?
No,
It
it
should.
automatically updated because it told me that I was due to join an hour ago, only I couldn't. I hadn't realised.
Okay.
Okay. So we went through the first part of the Rolang crash course, and I wish you guys had watched that if we want to continue, or we can move on to continue the learn Rolang by example.
Hello.
Which do you want to do, Kirill?
Either is good for me. I just like being here.
Oh, it's great to see you. Great to see you. Glad you're here.
I think if you're in the middle of something, we shouldn't intrude. So
Well, we'll
please.
try. We'll do it the next segment of that, and then maybe we can switch to the. We'll see how people feel.
Sure. Just for the record, Jim, I'd actually like to say how sorry I am about hearing about Gary. Tragic, sad news. I know we chatted and lots has been said. However, there is a relevance to that as well. I bought some Rev, which I'm going to transfer after this meeting. I think it's a wonderful idea. What a great eulogy. If people can send a bit of Rev and then we can help make his dream happen, that'd be brilliant.
Yeah. Well,
However,
I think Marcia and her brother really like the idea. They they think it's what Gary would have wanted, or would appreciate anyway. You know what I mean? It's a lottery ticket. It could be worth 10 or 100 times its value in 5 years or whatever.
let's hope so. Let's hope so. There is a reason for raising that beyond just heartfelt sympathy as well, which is unfortunately in the course of doing that, I got rid of my MetaMask and now I can't get my R-node to work. I seem to have lost the address. So when we switch to the tutorials, we might have to fix or reinstall my R-node, or I'm not sure what my address is even. So I don't know if there's a way of recovering that.
Well, yeah, you can always use the Bootstrap address. We can always add that back. You're not working on mainnet anyway, generally, right?
No, exactly. I mean, it's no big deal apart from the fact that it buggers up our session. But as OKK will see, it's quite good for us to bounce about looking at different things. So if we have to fix my R node this week, fair enough, and we can do the tutorial next week. So
right.
maybe we could have a look at that at a natural breakpoint. But for now, I'll let you continue. I just wanted to give you
So,
forewarning.
right, you lost the private key to that account?
Well, I can find, yeah, well, I can find one address with a private key. And when I tried to use that account on MetaMask, my rnode wasn't working. I'm not sure. That might be the rdev address I gave you. For
Well, you have to understand that, you know, that if, you know, when you have rev on localhost, you know, if you rebuild, if you go back, go back to your bootstrap or snapshot, you're going to lose it because it's not in the snapshot. And
let's look at an example.
Whoops, wrong thing, wrong screen.
Just before we continue, okay, how much do you know? I mean, are you a Roland expert and an rnode expert, or have you just joined and you're learning that an rnode is a miner?
I'm not a Roland expert. So this is my first time learning this.
Yeah,
so I'm actually very much interested.
Yeah, it's brilliant, mate. Please keep coming, even if it's painful at times. It is the best thing I've ever done in IT. I can't say stronger words than that. But yeah, all will become clear to all of us in time under Jim's great guidance. Please, Jim, carry on.
Right, and remember that, you know, if you have Rev account in Robot, Mainnet, Testnet, or localhost, it's a different rev. I mean, it's not going to show up in a different network. Okay, so you know, are you when you go to access an account, you know, it has to use an account. It has to have rev on that address. All right.
Yeah, that makes sense, Jim. I went to localhost. We'll see later. I went to localhost in MetaMask, and I got stuck because I didn't know what the chain ID was when I tried to add a custom component configured to port 8080, which is my single rnode network. Anyway, sorry. I'll shut up now. Please carry on.
Yeah, and we can, you know, part of what we do in these sessions is we help each other. So we can certainly look at your problem later. You can share your screen, whatever, and we can talk you through it, and it'll help everybody. Okay, so I will continue one more section of the video. Okay, and basically what we covered so far was the match statement and the send and the receive in parallel here. Do you guys have any questions about this example before we go on? We bind message, the identifier message to the value hello. Okay, well, this has a star on it right now, so I'm not sure this would run. I think it's going to get an error, but that's forcing it to be a title. And I guess maybe we should actually play with this and straighten this out because it gets to be really confusing. If we where is it? Well, let's see where it goes from here. We'll see if we need to go over it. Let's see. We can look at the Towers of Hanoi. You familiar with that? Okay, you guys have already been through the Towers of Hanoi. So maybe that's not necessary too much. But if we, oops, I'm doing the wrong thing here. How do I, let me, I'm having trouble getting
Process
out of,
is
out of
process or name.
full screen here. Okay, so the thing is, okay, here we have, we're sending a process X to a name Y. Okay, and X is a process because the identifier matches 2 plus 2. So we create X to represent 2 plus 2, and 2 plus 2 reduces to 4. And so we get a 4 in the output. Okay, now, if we put a star here, then the X is the process with the name X. I mean, no, X is the name of the process X. All right, so we have a name here, and if we explore it, we get a problem. Name variable used in process context. So, so we can fix that by putting a star here, so that we're sending a process to a name. We're making the name X a process. Are you? We're not getting you if you're talking to us, David. So does that make sense?
Yes, it makes sense.
All right. So I guess it's up to Rich and Kirill. Do you want to see the Towers of Hanoi problem again?
I'm not sure I've seen it, Jim. Always good to see easy-ish row line code. So for me, I'm happy to carry on.
Okay, good. I you know, reviewing this video is going to help make the next one, right? And so we're doing real work here. And for that, we will get Rev, which is another issue which we want to bring up before you guys go, which is we need to go over the payment sheet and see where we are with that. But we'll do the Towers of Hanoi first. Oops.
I'm going.
I don't know. Probably we should say message is an identifier that can be represent either a process or a name. We heard this already. It's confusing when I call it a name. It's an identifier for the process. Hello. If I put a star here, we can look at the Towers of Hanoi. There we go. You familiar with that?
I don't believe so.
You don't?
No, I'm not.
Hey, we're not recording. They don't believe it.
There we are.
Oh, okay. So the Towers of Hanoi
Yes.
has some number of disks, with a smaller disk always on top of a bigger disk. And the idea is to move all the disks from the left peg to the right peg, using the middle peg as intermediate storage, so that you never have to put a larger disk on a smaller disk.
Okay.
Okay. And so if we look at doing that in Rolang, okay, we make a new variable result, which is where we're going to get our output down here. So we're going to send to the identifier result, which is a name. We're going to send any output that we want to see in our result. right? And the result is going to be something like this. It's going to be instructions on move to top this, from the left to the right, blah, 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 until all the disks are moved to the end post in the biggest one on the bottom, right?
Mhm.
Okay, standard out, we don't really need to get into. This is the way we can write to the node log. Okay, and we can look at the log later. When you're running your own R node, you're going to want to look at the log. You can see the log on Robot. We have a URL for that. But usually you don't need to look at the Rolang log. It's only in case of some problems and debugging and things that you might want to look at the log. And this is called the powerbox function because this is outside of Rolang. We're not sending and receiving a message inside Rolang. We're actually sending a message outside of Rolang. Okay, we're not sending, I mean, standard out represents a channel that's not an R node, not a formal row calculus channel. Did I confuse you there?
No, I think I understand that. You're just
The
saying that
power
this is
box
just-
function. There's a way of connecting to the outside world.
right.
And it's also used to access, internal R chain, R node things like blocks and things on the chain because they're not really part of Rolang. They're part of
Right.
R chain, but they're not part of Rolang.
Right.
So that's, we create the identifier standard out to write to the log.
Okay.
Okay, and then we create several other names. And I guess as we go along, we need these different names. Now we're going to create, we want to do a move operation. We want to move pegs, move disks from one peg to another. So we're going to, any questions so far? Oh, any questions so far in this? David, Precious, Rich, Munchalov. Was this clear?
For me, yes.
Yeah, I've gone through the Tower of Hanoi code before, but I still have troubles really understanding, or would I say replicating the code? But I guess I'll have to look into it later anyways.
Okay, well, we just started going over it, so we'll see when it's finished.
Okay.
Send to the channel, move the height of the stack, and we say we have the height in the stack is 3 here. We could make it 4, whatever. And then height, the identifier height becomes associated with, refers to the process 4, right?
Mhm.
Okay, so we're going to move 4 from the left to the right using the center as an intermediate place.
Okay.
And when we're done, we're going to send an ACK, acknowledgement.
Okay.
Okay, that's because everything happens at once in Rolang. If we're going to have any order to things, we have to enforce that by sending messages because that's the only thing we can do in Rolang is send messages. Okay. Now I'm making a contract. Now a contract is something new that we haven't discussed before, but a contract is really syntactic sugar on a persistent read, wait for. We're going to have a wait for, and the wait for is going to wait for the height left height so we're introducing a new thing here. At sign from. Okay, and the at sign does the opposite of the star, of the asterisk. It says the name of the process from. And that's basically so I don't have to put an asterisk in front of from everywhere I use it as a value. So I'm going to have, as a process. So the name, now I could have, without the ampersand there, I could put the star in front of from everywhere I use it. At sign 2. And so I'm going to move something from a post to a post using another post as an intermediate holding spot. And I'm going to return an acknowledgement. ACK. And what is ACK? ACK is a name I introduce up here. It's a channel, unforgeable name. Okay, so when I receive this pattern, and what is the pattern? It's just 5 arguments. So I'm going to wait for this pattern to be sent to this channel, which is move. Okay, so what did I do? Oh, so this for statement.
Jim, you're on mute if you're talking. Jim, you can't hear you. I think you're muted.
Oh, any questions so far?
I just wanted to ask, I think it was David, might have been, okay, but was it you, David, that said you're not quite sure of something, but move on?
Well, we were going to go through, move forward a little bit to see if you had questions. So do you have a question at this point, David?
No, not yet.
Okay.
I just wondered, David, what it was you didn't understand on the, because it's like, on the one hand, you are way better at Rowline and development than I am, but on the other hand, when you say you don't understand, you don't mean you don't understand it at all. You mean you don't understand it 100%.
Yeah, but I think what I don't understand is I'm not clear. Like, understand the way the puzzle, the way the Hanoi puzzle work. Understand the whole that you have to move the, what's it called again? The disks from one end to the other end. But I don't understand how the steps were implemented in this Roland code.
Right, and I think this is an interesting algorithm, which is a recursive algorithm I think people starting out with Roland have a problem understanding how to do recursive algorithms. And here we just specify what we want to do. We want to move X, some number of disks from the left to the right, using the center as a intermediate point. And we want to get an acknowledgement when we're done. Okay, so this is really a problem specification. We actually give it, say this is what we want to do. Then how we do it, it goes into below here. And basically, we have, oops, I'm not in the thing.
So on line 12, sorry for cutting short. On line 12, if we change that for comprehension to a contract, have you tried the outcome of that?
Well, if we can't do a persistent read here, can we make it we should be able to make it a contract, but
not when it's a video, right, Jim? And you can't edit the code.
Well, where is this? I'm a little bit confused about how we do this right now. Myself.
Tim, could I ask a question?
You know, sure.
Sorry. Could I ask a question around the same lines, 10 and 12, if you just refer back to the code?
Yeah.
Am I right? So I think, probably prove myself wrong, but I think I get the bind, I get send, I get generally the process calculi. Where I get confused is when we start using these other constructs, so things like the for comprehension, things like the match statement, because it isn't just processes anymore, it's also sort of like language constructs to do matches, to do the reading in. So I just want to check that I've understood lines 10 and 11 correctly. And I'm reading that as it is a tuple of processes. So height is a process. The quoted string left is a process. The quoted string right is a process. The quoted string center is a process. And the dequoted act name is also a process. So we've got a tuple of 5 processes sent to channel move. And then move is being persistent read with those 5 concrete processes that are on line 10. And it is being matched in the for comprehension to these names. So now we've got a name height, we've got a name from, a name to, a name other, and a name at. And so I see that as passing the 5 processes on line 10 to the 5 names within the for comprehension. Have
Right.
I understood lines 10 and 12 correctly? And if not, is that how other people are understanding?
Yeah, I think that's good. Now, okay, the code is a contract for move because we want it persistent. And I think that's what I'm explaining right now, is if we do it, if we read it only once, this isn't going to work. But if we do it, use a persistent read, it's the same as a contract. I think, the code, and 42, I mean, if I go back, 10 seconds here. We can see that what I did was I changed the contract to a for comprehension, right? We had this contract and I changed it to a for comprehension. And wait for this pattern to be sent to this channel, which is move. Okay, so what did I do? Oh, so this for statement is almost equivalent to this contract. The difference is this contract does a persistence. It doesn't just run the code one time when it gets this pattern. It runs this pattern every time. Every time we send 5 arguments to the channel move, it's going to run this code that follows in the curly braces. Okay, whereas the for statement here only reads it once. So if we send something to move twice, it's not going to do it. Now this is actually a persistent read, which is greater than equal instead of greater than dash. If I make this an equal sign, that's persistent read. But nobody ever uses that. Whenever we do a persistent read, people use the syntactic sugar. They make it a contract. So that answers your question, I think.
Yeah,
I have another question. Why would you ever want to use a contract statement rather than a persistent read?
It's just syntactic sugar, that's all. people expect contracts to write contracts on a blockchain.
Also, Jim, a nod to OO as well as to smart contract programming. It's the idea that you could call your contract a class if you weren't in blockchain, like an OO class, and then it just feels more natural, or a function. You're sort of calling something again and again, whereas you turn it into the full comprehension, which is almost nicer, removing the syntactic sugar and getting down to what's really happening. Then
yeah, well, one of the problems is that the difference between a persistent read and a one-time read is very minimal, and the code can be more understandable if you always use contract, because it's very clear that it's a persistent read as opposed to a regular read. Ordinarily, when you read something from a channel, it's gone. Rao's trying to call me. Rao, we're having a work study. All right. Okay, we'll go move on.
good for me.
Okay, so every time 5 arguments get sent to this move channel, this code is going to be executed. And this code is going to make another name, act1, so that it can sequence its own activities. And sometimes we see when we need act1, we add it to the new up above normally. We don't, we may not think ahead enough to realize we need an act channel. So here we use a match statement with more than one alternative. We use it like a case statement. We're going to match the height, which is 4, against the process 1. Well, it doesn't match because it's 4, right? So we're going to have this second case here, which is underscore. Well, it doesn't match an underscore. What is an underscore? Underscore matches any pattern. Okay, just a comment here that if our height is only 1, the only thing we have to do is move the top disk from the peg to the to peg. Okay, if we only have 1 disk, we don't have to worry about putting a bigger one on a smaller one, right?
If it what? You said if it what?
If the height is only 1, if we only have 1 disk to move.
Oh, okay.
Okay, we can move it We can move it directly from the from to the to. We don't have to. We don't have to use the other stack at all. Okay, because we're just moving 1 disk.
Yeah, that's true.
Okay, so when the height is 1, we just move it. Okay. Okay, and I don't care what the name is. I could have called this, I could have given this a name, like not 1. Okay.
Mm-hmm.
Now I've bound the name not 1 to whatever the height is. Okay. Okay, so since it's 4, it's not 1, and I'm going to do this case. And now I'm going to move 3 disks to the from, and the from is going to be the left. I'm going to move 3 disks from the left to the other, which is
The center.
to this, right, I'm going to move the 3 disks from the left to the center using the 2 as the intermediate post. And when it's done, it's going to return ACK1. So here I'm going to wait for ACK1 because in order for me to make the next move, I have to finish the first move. Does that make sense?
Mm-hmm.
And when I finish the first move, I moved 3 disks to the center. Then I'm going to move one disk from the left to the right using the other as an intermediate. Okay, so I've moved the top, so I've uncovered a larger disk on the left. And now I'm going to move that to the 2. Okay, and then when it's done, it's going to write to ACK1. Now I have to be very careful using the same name for an ACK channel because I have to make sure that they're serialized. Otherwise, I'm going to get some really weird bugs. Some people writing Rolang will never use the same name twice because they're not sure, which thing's going to get executed if more than one thing reads the same ACK channel or has the same return channel. In this case, since we only get here when we read ACK1, we know it's empty and we can use it again. And then again, when we move the larger disk to the 2, then we're going to move height -1 from the other to the 2 using the from as the temporary. Okay, we move disks off of the from, well, off of the left. Okay, and then when that's done, we return a nil, the acknowledgement. Doesn't matter what we send to the acknowledge channel. We point out that since not 1 is bound to the height in lines 22 to 26, we could have used not 1 instead of height. We could just change height to not 1 and get the same result.
Jim, there's something that I've been trying to verify. Now, in my mind, contract works the same as functions in other programming languages. Is that correct?
Wrong, totally wrong. Okay,
But
function. This is row calculus. It's not like other languages, but to some extent, it serves the same purpose as the function. I think that's what you're saying.
Yes,
but it
yes.
doesn't behave as a function. It's not.
No. I don't mean behavior. I don't mean in terms of behavior. I mean in terms of usage. For example, now if we look at this contract now, we can see that on line 22, 24, 26, we're using the move contract the same way we would use a function. So we have the parameters and we're just changing the parameters just the same way we would do if it were to be a JavaScript function or
Yes.
that's what I meant.
Right. It's a recursive function. It's a function that calls itself.
Yeah.
Where's the recursion, Jim? I mean, I can see we're calling it multiple times, but where's it calling itself?
Because when we call move, it calls move.
Ah, yes, of course it's recursive. So, yeah, thanks. Yeah, because it goes back to the start. But that's interesting because I don't, thank you for what you said, David, because I hadn't been thinking of move as anything other than a name, or as opposed to actually being a contract.
hence I struggled to see where the recursion was. But yeah, if we were on line, whatever it is, 12 or 10, where we define the move contract, then clearly you've got recursion. So my thinking or question is, how do you relate the two sets of concepts and behavior? Because on the one hand, maybe move isn't a name. Maybe move is simply the name of a contract, but then the contract itself is actually a for comprehension where move is the input tuple, at which point you've got a tuple of processes being matched to the other side of the for comprehension. So on the one hand, you can think as I'm describing it in terms of processes and names and these funny things called matchings that exist within for comprehensions, etc. And on the other hand, you can think of it in a different context, which is the context that David just raised, where it almost, as a result, the emergent behavior is for the contract or the for comprehension to kind of act like a function, and particularly when you use the syntactic sugar of contract. I hope that wasn't just waffle. I think it made sense to me. Hopefully it helped others.
Yeah, I think that was helpful. So I guess we have to think of, sending a pattern to a name is the same as the same function as a function call in another language, that what happens when we do this, when move receives this pattern, is this code is executed. So it's like a continuation. This is the continuation for when it receives that. And when we have a for statement or we have a contract, we have a piece of code that gets executed when that pattern is received by that name. And there's no for in here. Here's a for. So when one argument is received from list, okay, and when list is one argument, we're using list to store the list. So when list has one argument, which is a list, and list and Erlang are in square brackets. So this is an empty list that we initialize, that we send to list, to the name list. So now we read from the name list one thing. Well, it has one thing. It has an empty list. So then we're going to read that. We're going to, so prior is going to refer to the empty list, and it's a name. I don't know why sometimes it seems like it's a process, but in a for, when we read, it's into a name. So so then we write to the lit we write to the name list. Now we consumed what was in list. List is empty now. It doesn't have any value. We read it. Okay, so now we read from, we write to the name list. Okay, the prior, which is the empty list, concatenated with the list containing term, which term is the argument to the log contract, log term. And really, it should be message. I'm going to fix that, because people, although in the structure of a block, the code is called a term, and formally it's a term. And with respect to the log, it's a message. Okay, so I forget what the question was, but we can see that this is working, and I guess we should continue with the video, all right?
Yeah, I think I asked the question, how's it recursive? And from that, we got back to David's
okay.
question on contracts, and I
Right.
think you've answered it thoroughly.
Okay, so this is the code. Okay, this is the code of the function, or of the move when it receives 5 arguments. This is the continuation. This is what it does, and it calls move 3 times here. So that's what makes it recursive. Because when it calls it, it's running it with different arguments, the same thing. And it's sort of interesting logic, and how it breaks down the problem into simple steps.
Jim,
Yeah.
I think this is the best thing I've ever seen in Rolang. It might help that I've done many of these sessions, but what we're really doing here is, in quite a simple example, we're showing how the process calculi operates in conjunction with some matching operators, which is the actual Rolang language. And we're showing how that can be used to program in functions. And we're doing that recursively with recursive function calls. And beyond that, we're actually using that functional usage to do something real and useful, something with semantic meaning, namely solve the Hanoi Towers problem. And it's not many lines of code. So I just wanted to say, well done. I think it might need more work. You might want a little video in the top right with the puzzle moving as you step through the code. So you can see. I don't know how we make it more accessible, because there's some very complex concepts going on here. But I think you've encapsulated it beautifully. Well done.
Yeah, we could put the output of this into a script, and have the script do the animation, right? But that's an exercise for the for homework.
I would love the whole video, Jim, because I think this is brilliant. I'll try and be a bit more quiet now and give other people a chance to speak.
Yeah, no, please. This is our review of the and it's of the tape, and it's important, mainly for clarity. And I think your comments, if nothing else, will give an indication of the content that we need, that we should provide.
Thanks.
Okay, so when we get down to 1, the last disk that we're moving, okay, we first move 4, 3, 2, 1, but we say move the top disk from the to the to, and we're sending to the log, move the top disk from the to the to. Now, what is log? Well, we introduced log here, and we can see that we have a contract log down here, which creates a list of all the things that we logged. So we have a little utility at the end of this that logs. We probably didn't need to complex this so much. One of the things the log does is it makes sure that everything comes out in the same order. We serialize everything by by adding to the list and prioritizing it so that we get the list in a correct order, and that can become a problem. We can look at if that changes. And then we're done moving a disk. So when we get an ACK back that we've actually logged it, we send an ACK to a nil. And if we explore this, we can see the process. And if we make this a little simpler, say we do 2, height of 2, move the top disk from left to center, move the top disk from left to right. So the smaller disk got moved to the center, the larger one got moved to the right. And then we move the top disk from the center to the right. And that moves 2 disks from the left to the right. Okay, and similarly, if we do 3, whatever, we can verify that this works correctly in terms of moving the whole stack from the left to the right using the center as an intermediate. But you'll notice sometimes we use the right as the intermediate in order to uncover the larger disk. Okay, let's simplify this a little bit and take out logs. Okay, what we did here was we wrote the list. Where do we write results? Oh, here. So when we received an ACK back from the move, we write the list to the result. That's kind of a little complicated. So let's just go right to the result here. So we're going to write this directly to the result. Now the question I have in my mind is, are they going to come out in the right order if I don't use the log? And okay, so we're never going to get we're not going to write 2 arguments to result. We're just going to write 1 argument, although we can see what happens there. But we're never going to get ACK1 back because sending to result, nobody's going to ever write to ACK1. So we're going to simply have to acknowledge ourselves and do a nil. Whoa, does that make sense? Okay, when it was done writing to the log, it would get back an ACK1, and then it would acknowledge that the move was complete. ACK1. Looks like I messed up here. We have a bug in the developer interface where the cursor got bug here. I'm going to do Control A, Control C, delete. I'm going to paste it back in here, and hopefully. I don't know why we have all these parentheses. I make this ACK1. Okay, because that result. Okay. So we're not using the log, but so we're going to always acknowledge this after we print a thing. And if we explore, we probably get an error. ACK1 on 11.9. Oh.
Is it because you spelled ACT rather than ACK?
Yeah, and because I really sent it to the wrong thing. If we look here, we can see it sent it to ACK.
Mm-hmm.
Okay, not to ACK1, because ACK1 was never introduced. Okay, so what happened is we got this unforgeable name here. We got to the output. Confuses things. That's because we don't need this anymore. We don't need to write the unforgeable name here of it. What? Okay, so now if we do explore, we see we get the moves here. Now let's do it for 2 and explore. Top. Okay, left to center, left to right, center to right. Okay, we're always getting these in the same order. Thing is, in Rolang, sometimes we have to be very, very careful to make sure we get things in the right order. And because we're getting an acknowledgement back each time here, I think we're pretty safe that these are always going to come out in the same order. However, today's Wednesday?
Yeah.
Okay, I have 1 o'clock, which is the members meeting. You can feel free to join us in this room, actually. Member Zoom hangout. So if I go to the collab, I probably have this in a number of places. Probably having Rolang testing. We have ROCK. Should be in this channel, I guess, actually, now. You can call in robot testing ROCK. What? I don't have it. Paper? Well, let's look at paper more generally. And that doesn't give us anything. So we go to the, how do you spell scissors?
SCIZZOR.
SC.
I'm pretty sure it's ZZOR.
ZZ?
Oh no, I'm wrong. SSOR. SCISSOR.
Okay. Let's look at this rock, scissors, paper example. Any questions about towers?
No, I follow.
Okay, so I make you're familiar with rock, paper, scissors, right?
Yep.
Okay, so there's a winner, which is the result, because when we explore, the first variable is the result, and then we have Alice and Bob, who are the players. And we have Alice send a rock, paper, and a scissors in parallel.
Okay.
So we send a rock, paper, and scissors to Alice in parallel. All right. And we do the same thing. We send a rock, paper, and scissors to Bob in parallel with sending the rock, paper, and scissors to Alice. They all happen at the same time.
Okay.
So now we have a bunch of wait fors here. We wait for a rock from Alice and a paper from Bob, and then we say winner, Bob wins, paper over rock, right? And we wait for a rock from Alice and a scissors from Bob, and we say the winner is Alice, wins, rock, beats scissors. You follow? Okay. So now we explore. We have Bob wins, scissors cuts paper. Bob wins, rock breaks paper. Bob wins, paper over rock. Oh, Bob always wins. Isn't he lucky? Let's play again. Oh, now Alice always wins. Explore again. Oh, now Bob wins one, Alice wins one.
You're on mute, Jim.
Hey, Jim, can I hear you?
Sorry. Yeah, so there were 3 games that were played because there were three things put, but when Alice wins paper over rock on one game and Bob wins paper over rock on the other second game, the third game, they both drew scissors. It was a tie. All right, that uses up all the inputs. It was a tie game. we could add we could add cases here for if the tie games, if also we wanted to. Any questions on that so far? Okay, we'll continue. So now you know row length.
Yes, I do.
Now, if you on this page is the learn row length by example. And let me show you again. Learn row length by example here,
Okay.
which you can go to and we can see things. And the next time we're going to go through and make sure you understand each of these things.
Cool. Sure.
Okay. And the basic thing is object capabilities, which is different about the way the security model works. I'm not sure this example is the best, but in any case, we'll cover it in a future work study.
Okay.
And then I think after the second one, you'll be ready to actually contribute to some development in rGov. We're working on a chat capability.
Okay.
And there's something, it's going to strain your brain a little bit to understand the Rolang of how that works. But the basic work is already done. So it's making an interface to it is not quite as challenging. still challenging, and there's a lot to learn. But
cool.
So we're starting in this room in 9 minutes. Now I'm going to take a 9-minute break.
Okay.
Any final questions or anything?
No, I appreciate your time and your explaining of Rolang.
How do you feel about Rolang?
Well, I think it's always I never know how long it'll take for me to start to look at a code and understand it and see what's going on. But I think I get it a lot more than I thought I would get it. So that's exciting.
Well, you can always watch this video. You'll forget.
Yeah. But yeah, so far so good.
Awesome. Welcome aboard, and I hope.
Thanks so much.
That was nice.
Jim?
All right. Questions, comments?
I'd like to ask Okeke how he feels about Rolang. Same question.
Precious,
Yeah, please.
I think that question was for you.
Yeah, sorry, Precious. How do you feel about Rolang? I just thought we could ask you the same question.
We're not hearing you. Well, we can
Hear me?
use. There we go. Not hearing you. No.
Can you hear me?
Hello.
Is this better?
Yeah.
All right. So I
Great.
think Rolang is an interesting but it's a complex language, and I have a lot of homework to do on this. Trust me, David will be very much occupied with questions. He knows I'll ask him a lot of questions about this, But please, I'd like to ask a question about this a little explanation on the Towers of Hanoi puzzle. During the lecture, and I would like to know a little bit about it.
What about it?
I'd just like to have an idea of what it means. It's the first time I'm seeing the Towers of Hanoi puzzle.
Could you bring back the image in the video, Jim? Would that be a good start point?
Okay, let's, we can watch this. Where am I? Looks like there's silent. Well, we can look at it anyway. I didn't need to find a good one here, but we have 3 tags, and here they're labeled ABC. We call them left, right, and center. We want to move desks from A to C without, so they are in the same order, red, green, blue, from the top to the bottom. Okay, this is like a contract.
Okay. Oh, so this was the solution. This is the solution that you followed, Jim.
I don't, well, it's got to be the same. I mean, I just found this video now.
Oh, okay. Yeah, because it looks, you know, the steps I saw earlier, much earlier. I mean, not today, much earlier. It's a little bit different from the way you implemented yours. So.
Let me put this on faster. All right. Okay, so it's, you know, they use a slightly different ordering of the arguments, but this is basically our move command. And it should show us. Oh, it's not showing us the pictures. I was hoping it was showing us the picture. Here's the pictures. Okay, so we move from the left to the right. So these are the moves. That's what this is what I was looking for. Now I got to get the bigger one out from under, so I have to use A as a temporary. Then I can get the larger one out and put it on top. And now I just need to move one, and I move it directly from the from to the 2.
So the key is that you never put a bigger block on a smaller one. You never put blue on green or red, and you never put green on red.
Right. Jack, did that help?
Jim, for me, could you post 3 things in the chat, please? Could you post that video so that we can have a look at the things moving around? Could you post the video that you did the other day? And when we're finished, could you post this video? Because combination of all 3, I think I can suss it out if I keep rewatching it, and hopefully the same is true for other people.
Okay, I'm going to put it in the chat so that we can where should I put it? Roland Collab. Towers. Oops, I forgot to put it. And then we put the okay, when we put the code in here, we use the Scala highlighting. So we use back quote, back quote, back quote, or back tick. We put Scala, and then we put the process, and then we use 3 back ticks to end it. Okay, here again, I don't know why this didn't indent properly. Okay, now, actually what we wanted to do with this.
I don't think you're sharing.
Jim.
Oh. I'm sorry about that. Okay, so I'll put the code here, but should I take out the list? I'll leave the list in there. What the hell? And the code, and I'm putting this in the Roland channel here, and I'll and we want the video link. And I should probably put the code in there also for the towers. I mean, for that's what we're looking at. Towers. What I was looking at here, and I see you entered something, collective intelligence, which is a place we could put stuff, but I'm trying to get expand the number of people involved in the collective intelligence discussions. So did I find it here? Scissors. Okay, scissors is here. Jump. And so copy this whole thing. And I'm going to go back here. Where is this? I'm going to go back here. Okay, and I'm going to, oops, collab. Sorry. And I'm going to actually split this up. Oops. Oh, X. Okay, and now I'm going to do a backquote, backquote Scala, and I'm going to put eval. So I want to evaluate this. And I'll put the code in there. And I'll put the 3 back quotes. And it didn't work. Okay, because it didn't work because we're printing the log here. We're not printing the we're the we're using the row IO standard out as the output for robot on Discord.
Jim, quick question. What time does this session end?
I guess we're done pretty much. It's already overtime.
Okay.
Okay, I'm just
I'm having.
we're just doing some housekeeping now. You know.
Okay. I should be on another call now. I have another call now.
Yeah. So we'll see you. This is you can just see if this works. Oh, I don't know why it didn't work. Oh well. Print 2 + 2. Okay, so it looks like the robot is down. So I'm going to. You can go, David, if you haven't.
Oh, okay. All right. See you guys later.
See ya.
See ya.
And we go to robot.net. And I probably should have done this. And we go on as our chain. AIN. And then we have our shared password. Which I won't put on the thing, and I don't know why. And why I can't type it. No, boy. Now I have to figure out what the password is, huh? You can log in as Jim. And hopefully I know the password here. And then I can do a sudo su dash, which would make me, oops, I don't want to do that. I want to do a sudo su rchain. So I want to become rchain. So in Linux, if I have sudo permissions, then I can do it using my own password. And we really shouldn't change the password. Now what happened? Sudo, oh, I didn't do a dash. Okay, the dash means set up the environment exactly like the rchain account. So I'm going to echo exit. Well, I'm going to exit. It looks like it exited completely. Jim.
You have another window open.
Yes, I know. I know. So I can kill that window. That was the one where I was trying to log in. Oh, that's bizarre. It looks like So in order to become the RChain account, I need a dash. For some reason, I thought I lost the window. Okay, so now I'm RChain, and I do PM2 status, and it says it's running. PM2 restart robot. And if we do a print colon 2 + 2, we get, oops, we get a 4. Okay, so let me copy this whole thing. Control C, escape. Try again if you succeeded first. Syntax error 113. And I see what I did wrong. Unfortunately, it doesn't, the robot doesn't do modifications. It should. Control A, Control C, escape. Okay, so the power box functions are specified within backticks. So I need to put a backtick here and a backtick here. I need to go to the bottom. And voila, it works. And I should probably delete some of these things that didn't work. But that's just housekeeping. And any of us that are admins in here can delete stuff. And we usually, you know, in the Erlang testing, we don't really care if stuff gets left there that's garbage. But
Pretty nice setup there, isn't it, Jim? The fact that you can just run code and share code from sessions in here is really quite handy.
yeah, I mean, that was the idea, and we used that for quite a while. I suppose we should put in here. Well, let's see what's pinned to the channel. Oh, we don't have the
Precious, are you on Discord?
yeah, we need Mac robot RChain.
Precious?
Yeah, yes, I'm sure, please.
Sorry, are you on Discord?
Yes, I am. I was asked that, but how can I get added to?
Yeah, I was going to say, would you mind sharing your username and I'll add you to the Collective Intelligence chat? It's only myself, Jim, Kirill, David, and one other. But if you want to, I can add you.
Okay.
If you'd rather not, that's fine as well. You want to leave it for now?
So this
Yes,
is This
fresh
is information on this article. I'll put the link in there and pin it to the channel.
Oh, cool.
So if you want to use MacRobot, it's a macro processor. Okay, so we'll pin that to the channel. And here again, everybody should have equal power in the collab. So you should have admin privileges if you're willing to contribute and participate here and earn rev doing so.
Precious, what's your username, Precious?
Okay, hi. Username is Fresh Code. That's my username. Discord.
PREC.
Yeah, PRESHCODE. Fresh Code.
Press code.
Yes, that's my username.
Maybe I've spelt it incorrectly. I've got PRESCODE. Is that right?
No, it should be an S and a H after the S.
Oh, fresh, like fresh.
Yes, fresh. Yeah,
Fresh.
short for precious. Yeah.
Cool. Fresh code. Yeah.
Yes, please.
I'm still struggling to find you. I'm not sure why. Let me try adding a person.
You see you on my screen? I type, it filled that in for me. Oops.
Okay.
Control Z. Control C. So if I go here and I put in fresh code.
My Discord, it's not showing for me.
Okay, so here we've.
Could you add fresh code to the
chat? I'm about to do that now. Yeah.
Yeah. When I just do this, I'll just put the fresh code, Rich. David. I'll put you all. Who else do we have? Who am I leaving out? But where's the Zoom? I don't know where it is, but I'm gonna turn the meeting, see if that helps. Oh, okay, stop share. Okay, so Munchlove, duh. Sorry, Kirill, I forgot you. But
How could you?
yeah, he's not in the least bit forgettable. Yeah, I'm getting, my brain is working not so good every day. I lose more.
Can you check the, sorry, Precious, can you check the chat message I've just sent?
Yeah.
1409.
Yeah.
I just sent it in the chat.
All right, there is a reason. Sorry to be a pain. There we go. Hopefully I can send a friend.
Yeah.
It's fine. It's fine. Okay, I've been invited to the group.
So I tagged you all here.
Yeah, I'm here.
So you can go and send a friend request or whatever.
Yeah, send one as well.
Send a message.
Thank you very much today for this training. I really appreciate it. And I'll be back for the next one.
Very good. It's good to meet you.
And I'll be back with more questions for you, Mr. Jim.
Right. Well, I think we have a number of videos in the can from that you can watch. You can watch the. Did I put the video in the channel?
Well, you didn't put this video with us, but you put the main video with the guy from yesterday. Yes.
Okay, and if you go to the rgov.robot.net and click on the Learn Robot Plan by Example, you can start following the examples and see what, and come up with some questions that you may have for next time.
All right, we'll do that. Thank you very much, everybody.
Very good. Thank you. Goodbye, folks.
Bye.
See you all.
Bye.